Welcome once again in the third video of this chapter, chapter 9, soil. In this video, we are going to talk about properties of soil. But before we plunge into properties of soil, let us first do the recap of what we have learned in the first two videos. So in the first video, we talked about soil and its importance. We also talked about the soil profile. So we talked about the O horizon, which is the organic matter, which is very rich in humus. It's actually the upmost part of it. Then we talked about A horizon, which is the topsoil, B horizon, which is the subsoil, then C and the D, which is the bedrock. So all these types of horizon helps us to understand the composition of soil. What is it actually made up of, and how deep should we dig for a particular plant? Then in the second video, we talked about types of soil. So we talked about loamy, sandy, clayey, and also silt. Now we talked about that sandy will have bigger particles. Clayey is going to have very fine particles. Fine means very small particles, and loamy is there somewhere in between. So it's a mixture of sandy and clayey. While the silt soil will be having very less amount of sandy and clayey soil. It will be very rich in humus, and it is very dark. It is brown or black in color, and accordingly we saw the fertility of it. Now in this video, we are going to talk about the properties of soil. So based on the types, now we will study the property. When we learn about the properties, then we will understand how come so many soils are of different types and what are the different uses. Now, before we start doing the properties in detail, let us do a simple activity. Now, this simple activity is you need to take different samples of soil. You can take it from the roadside, you can take it from your garden, you can take it from near to your school. So, take different samples and add water to it and knead it well. The way mama makes roti, so for roti she's making dough. So, this dough is made by like this. So, you have to knead it and then try to make a ball. Try to make a ball, cylinder, ring. When you make all these things and you dry them, you will see few of them are breaking, few of them are as it is, few of them you are not even able to make. It is not going to take that shape. So ball, probably they will be able to, but ring is going to be difficult. So try it with different soils and observe what happens. Why there is a difference in because same kneading has been done for all, same person has used it for all, same amount of water has gone into all. So why is there a difference between the quality of objects that we are getting? And you also have to find out with which soil it is best to do, because that is the soil which is used to make toys, the soil toys and the statues. So this is something which you will have to find out by doing it. So try doing it, and I'm sure you're going to really enjoy it. So the properties of soil. Now there are three main properties that we will be talking about. This one, the first one is percolation rate of water. Percolation means the way we have studied in the sandy soil, like it is the way water passes through the particles, whether it is sandy or clay or loamy. The rate at which the water passes is the percolation rate. Then you have moisture in the soil. So how much water is the soil having? And that is why you must have observed that few of you must be watering the plants once in a week. Few of you must be putting the water maybe every day, or it is twice a week or thrice a week. So why there is a difference? It is because of the moisture content of the soil. So if there is moisture, you won't be watering it. But if the moisture content is very less and it evaporates very fast, then you'll have to keep on adding water. Then there is absorption of water. So there are soils which absorbs water a lot, and there are soils which will not absorb water, but just let the water pass. So all these properties of soil will then help you to find out which crop should be grown in this soil and what is the use of this soil. But before getting into the first point, that is percolation, let us study the structure of the particles which are there. So the size of the particles. So if the size of the particle is big, the spaces between the particle is also going to be big. Okay, so if you see the sandy particle, they are going to have, because the particles are big, the spaces are also big, and the clay particles are very, very small. So that means the spaces are also going to be very, very small. More the space, more air it can have, but it is also going to get the water pass very fast. So it is going to drain very quickly. While less the space, very less air is going to get trapped, and it is not going to drain the water very easily. So there are chances of flooding. So by looking at the second picture that you see, I have not named it. So just try to figure out first image is of which kind of soil and the second image is of which kind of soil, and then which one is going to retain the water better. Try writing the answer in the comment box. Then you have percolation of water. So percolation rate is a speed with which the water passes through the soil. Water percolates faster through sandy soil because it has a lot of spaces between it, and slower through the clay soil because of the less space. Now, how do you find it? So what you can do is you can take a pipe. Dimensions are mentioned over there, but even if you don't have dimensions, you don't have to worry. Just take a pipe, go to the ground, put it inside the ground, and pour an exact amount of water. This exact amount is very important. Okay, so pour an exact amount of water. Just see your glass at your home, whatever measuring jar you have. Just pour a specific amount of water into it and observe how much time is it taking for water to get inside the soil. Okay, so once it is, and why we are using a pipe, so that it doesn't percolate here and there, and we know the exact, so the size of the pipe is exact, so we will know in different soil you have to use the same pipe of the same circumference. Okay, so by this method you are going to find the rate of percolation, which is the amount of water upon percolation time. So suppose out of 200 ml, so it is 200 ml, you tried percolating 200 ml. And how much time did it take? Did it take 1 minute? Did it take 2 minutes? Did it take 60 seconds? So whatever it is, when you calculate, you get rate of percolation. If it is in seconds, then please convert seconds into minutes for this numerical. So we always have numericals in maths and physics, but here also we are going to have numericals, and maths is extremely fun to do when you do it with practical. So try different soils, try different amount of water, and find the rate of percolation for them. So this is how you will be finding it. Okay, now let us get to the next point, which is the moisture in the soil. Now soil contains moisture. That is obvious because our atmosphere also has moisture. Moisture is all around us. During monsoon, the humidity is, you feel humid because the content of moisture is very more. So here the amount of moisture is different in different types of soils. The clay soil will contain a lot of moisture because it retains a lot of water, while the sandy soil is going to contain least moisture because it has a lot of space, so it allows the water to drain out. For this, again, there is an activity which you can do. And I'm not telling you to have a boiling tube. This your teacher can teach you in the school using this boiling tube, but at home also you can try this. You can have a vessel in which you can put soil and heat the soil. So when you heat the soil, and put a lid also, and take a small vessel and put a lid, and please observe it with the help of your parents. Do it and observe, don't let the vessel burn. So put a lid onto it and then see, you will be able to see the water vapor condensing on the lid. So if there is a water vapor, more the water vapor, more is the water in the soil. So more is the moisture in the soil. If the water vapor is very less and the soil is totally dry, then there is no water, there is no moisture into it. So to find the moisture, this can be an experiment that you all can do at home also. Then the third point is absorption of water by the soil. Now, if soil has moisture, that means it is also absorbing water, and the type of soil depends on this property, that is the absorption of water. So clay soil is going to absorb most water because of the space, less space, and sandy soil is going to absorb very less water because of the huge space. Here also an activity is been given. So you have to take a glass and you have to take a funnel, and on that funnel you can put a filter paper. If you don't have a filter paper, you can take a white cloth which mama must be using to filter the water. So you can take such type of cloth which has some spaces in between it to let the water pass. And please take a cotton cloth, not the synthetic one. So take a cloth on the funnel. Funnel also you can prepare at home. So it's just a shape, a funnel shape. Try making a funnel also at home. So keep it in the funnel, and please take a proper amount of soil. So take whichever gram you want to take, and by this way you can also study maths. So take a proper amount of dry soil and pour it in the funnel. Now take water and start pouring the water into it. Now water you have to take a fixed amount, so maybe 50 ml or 100 ml or whatever you want to take. Okay, so start pouring into it. And you will see under from the filter paper or the cotton cloth, the water droplets will be coming down. Now there will be a time when the water stops passing through because the soil is full. So when the water starts dripping out from the funnel, it is not the soil is not letting it pass. That time you need to stop, and that is what is going to give you the absorption percentage of water. If it is completely passing through it, then the water absorption is 0%. That is, it's not even absorbing water. So you have to find out here the initial volume of water, whatever you take 50 ml, you take 100 ml, that is going to be U, final is going to be V, and the volume of water which is absorbed is going to be the initial minus the final. That is what is present in the soil right now. And how do you find the percentage? It's U minus V upon 50 into 100. This 50 is the amount of soil. That is why I told you, you have to be very, very particular of the amount you are taking. So please note down, measure it on the weighing scale that you have at home, and then you can do this experiment. Again, it's fun to do experiment. If you do it, it is really going to help it. So instead of just solving the numericals, solving the questions, try doing it. Try finding it out, and you are never going to forget the formulas and the way to solve a particular problem. So here is a numerical which talks about the weight of the soil, the initial volume if you take 250 ml, and 50 ml is the final one which is coming out. So if you see, the gap is around 150 ml, which is 200 ml, which is not there. So this 200 is actually absorbed by the soil, and the percentage is 400%. So this is how you find it. Then you have the next one. So in the second video, we talked about the differences between clayey and sandy soil. So here is the difference between clayey, loamy and sandy soil based on their properties. So the first property is the water holding capacity. Very easy. Clay holds a lot of water while sandy doesn't hold any water. Or very little water it will hold. It will just make it wet and sticky. Then the air content, again, poorly aerated. Aerated is a word that means it will have less air because of the less space, and sandy is going to have a lot of space. Clay soil is going to drain very slowly because of the less space. The water, it will not allow the water to drain that quickly, while sandy will be very quick. Loamy is somewhere in between, so it's always going to be the average one, the medium one, the middle one. Okay? Then there is easy for plant penetration, there is water needs. So based on these properties, you will find the differences. So this was about the properties of soil. Now we are left with soil and crop. So which soil grows in which crop grows in which soil, and why is it so? Plus certain topics like soil conservation, soil pollution, soil erosion will also be covered in the fourth video of this chapter, which is going to be the last video for the chapter. So stay tuned. We will be back with the fourth video very shortly. So please subscribe, like, share and comment, and we'll meet in the next video. Thank you.